Okay, then let's start. It was continuing the solving video. Now the next question is, if a particle of charge 1 microcoulomb is projected into a magnetic field B, which is equals to 2I cap plus yj cap minus zk cap, Tesla, with a velocity v, which is equals to 4I cap plus 2j cap minus 6k cap, then it passes undeviated. And if it is now projected now projected with velocity v equals I cap plus j cap, then find the force experienced by it. The important points here are, in the magnetic field B, the velocity, which is this much, they did not provide the j cap and k cap coefficients, but from this we can find the y and z values, because they said an important thing, that the particle passed undeviated, meaning either the angle between velocity and magnetic field is 0 degrees or it is 180 degrees. That is the only way the particle can pass undeviated. So the formula is equal to qvb sine theta, which is equal to force, where the equation was b, which is equal to b vector, which is equals to 2I cap plus yj cap minus zk cap, and v, which was equals to 4I cap plus 2j cap minus 6k cap. When we divide both the values, and v, which is equals to 4I cap plus 2j cap minus 6k cap. Now when we divide both the values, that is bx vx by bx, which is equals to vy by by, which is equals to vz by bz. That is meaning that they are either parallel or anti-parallel in direction. That is why we can write this. So it is 2 by 4 by 2, which is equals to 2 by y, which is equals to minus 6 by minus z. And value of y and z, which is equals to 4 by 2, which is equals to 2 by y, meaning y, which is equals to 1, and 2 by 1, which is equals to minus 6 or plus 6 by z, minus 6 by minus z, which will become plus 6 by plus z, where z is equal to 3. There is some glitch going on, but fine. Then we'll get the value of B field, which is equals to 2 I cap plus 1 J cap minus 3 K cap. This is the field where force, which is equals to Q V cross B. V is equal to I cap plus J cap. When we do vector product, force, which is equals to 1 microcoulomb, which is 1 into 10 power minus 6 times I cap plus J cap cross 2 I cap plus J cap minus 3 K cap, cross product here. We can do it in the determinant way, where force, which is equals to 10 power minus 6 I cap, J cap and K cap, 1 1 1 and 2, 1 and 1, 0 and minus 3. We will get determinant, which is equals to 3 I cap minus 3 J cap K cap 1 minus 2 delta, which is equals to 3 I cap minus 3 J cap minus k. Minus k cap. So f is equals to 10 power minus 6 times minus 3 I cap plus 3j cap minus k cap, which if we take the magnitude, we will get force, which is equals to, this is force vector, and normal force, which is equal to root 19 into 10 power minus 6 Newton. Now let's go to the next question. Okay. An alpha particle, that is helium 2 plus atom or ion, is accelerated by a potential difference of delta V, which is equals to 10 power 4 volt. Find the change in its direction of motion accelerated by delta V, which is equals to 10 power 4 volt. Find the change in its direction of motion If it enters normally in a region of thickness 0.1 Tesla, mass of alpha particle is given. Mass of alpha particle is equals to 6.4 into 10 power minus 27 kg. Okay, they're saying an alpha particle is accelerated with a potential difference of 10 power 4 volt. Now find a change in its direction of motion if it enters normally in a region of thickness 0.88, 0.1 meter, having transverse magnetic field or magnetic induction of 0.1 Tesla. The diagram I will draw. Now there is a magnetic field here. This is the motion of a particle. When it's under a magnetic force that is acting perpendicular, it will have a slight deviation. And to find the force acting on that particle, we need to use Fleming's left-hand rule, and through which we will find that the force direction is this way. So it will be, the path of the particle will be something like this. Let's take a tangent, and let's assume that this angle is theta, and this angle as well is theta. Now this is thickness, which is 0.1 meter. Okay, then let's solve the question. They're asking us to find the change in direction of the particle after it entered this magnetic field. And velocity, which we can find by half mv square, which is equals to qv, or change in kinetic energy, which is equals to work done, or in this case this is velocity. So velocity, which is equals to root of 2qv by m. This is the formula. Much better. And we know when there is basically mv square by r, which is centripetal force, and magnetic force, which is qvb. Then we will get radius, which is equals to mv by qb. This is the radius of the circular path. This is the radius of the circular path, and which we can denote in the diagram. Which we can call the distance from here as radius, or even this distance, which is equals to radius. And in this equation we can substitute the value of v from our prior equation, this one. So we'll get r, which is equals to mqb by root of 2qv by m. Wait a second. And we can take them inside by writing as squares. So it will be 1 by b 2qvm square by m q square. So q square q cancel, m square m cancel, where r, which is equals to 1 by b root of 2vm by q. The change in direction of the alpha particle is given by sine theta, which is equals to p by h. And from the diagram we can identify which is p and which is h, hypotenuse and where p we can consider the thickness, which is 0.1 meter, and h we can consider the radius as this one. This also can be theta, so this length will become p, and Wait a second, it's not sine theta. Yeah, I believe it is tan theta, which is not sine theta. It is tan theta, which is equals to P by B, which we will get it to be L by R, and R value we know. Substituting it, we will get tan theta, which is equals to L by L times B root of 2, I mean Q 2mv. Now substituting the value, we will get, or maybe it is tan theta itself actually. Wait a second. I'm not sure why they are considering sine theta here, but it's sine theta, which is equals to L by R, which is equals to LB to MV. And substituting the value of everything here, where length is sine theta, which is equals to length is 0 0.1, magnetic field is 0 0.1 Tesla, root of charge, which is equals to 1.6 into 10 power minus 19 times, I guess, 4, or wait, no, it's not 4. Since it is helium, it is 2 times 2 by 2 times of m mass. They gave it as 6.4 into 10 power minus 27, and voltage is 10 power 4 potential difference. Sine theta, which is equals to 10 power minus 2 root of, let's just write the final value, I guess. Sine theta, which is equal to, we will get 1 by 2, and sine theta 1 by 2, then theta value, which is equals to 30 degree deviation by 30 degrees. Now let's go to the next question. This is theta equals 30 degrees. The next question is, find the force experienced by the wire carrying a current of 2 ampere if the ends P and Q of the wire have coordinates 1 comma 2 comma minus 3 and minus 2 comma minus 5 comma 1 meter when placed in a magnetic field B, which is equals to I cap plus K cap, J cap plus K cap. Solution: the force acting on a wire, which is equals to ILB sine theta, or in vector form, force which is equals to I times or I L cross B and we will get to find L, we will need to subtract R2 minus R1. We will get L vector, which is equals to 1 minus 2, that is minus 3 I cap, 2 minus 5, that is minus 7J cap, and minus 3 we will get as plus 4K cap, and this is the L vector. Then force acting, which is equals to 2 times of minus 3 I cap minus 7J cap plus 4K cap cross I cap plus K cap plus J cap, which we can do determinants wise, where I cap, J cap, and K cap which is equals to minus 3 1 1 and 1 minus 7 4 minus 7 and minus 4. Delta, which will get it as I cap minus 7 plus 4 minus j cap minus 3 plus 4 and k cap, which will get it as wait a second, this was plus 4, so this will become minus, and it is minus 3 plus 7, which is equals to minus 3 I cap, wait a second, this is not minus 3, this is minus because I forgot to change it before, so it is minus 11 I cap plus 7 j cap plus 4 k cap. We will get force vector, which is equals to not magnitude but force vector, which is equals to 2 times of minus 11 I cap plus 7 j cap plus 4 k cap. Now let's go to the next question. In figure, which is this one, this is a semicircle of radius 1 meter. 2 ampere of current is passing in this way. It's in a magnetic field of this way, perpendicular like this, going into the plane. There is one more diagram that became a square. Yes. This is also radius. This is 2 ampere current. This is A diagram and B diagram. Here as well, there is a magnetic field inward. In this figure, a semicircular wire loop is placed in uniform magnetic field, which is equals to 1 Tesla. The plane of loop is perpendicular to magnetic field. Okay, the second loop, the current is in this way, but the current is going like this and this. In here, in this case, the current is going like this. Now we are asking find force on the loop. Solution. Okay, for the first case scenario, it's forming a complete loop because current is going and completing the loop. So the net force on this loop on in the case A, force net, which is equals to 0, but torque might or might not be 0, but net force will remain 0. But in the second case, it is not experiencing 0 force, it will experience some force. And in the second case scenario, current is going this way, where let's name it as A, C, and B. Force, fine, anyways. Force due to AC, which is equals to ACB, which is equals to force due to AD. ABC, force due to ABC is equals to force due to AC. When currenting is going in this direction, and so force on loop, which is equals to FABC plus FAC, and force which is equals to ILB sine theta. Here it will become 2 ILB sine theta because we are adding two loops. I mean two different forces, F which is equal to 2 times of 2 amperes. So 2, and since radius of loop was given to be 1, the length of L, which is equals to 2 times of R, 2 times of 1 is 2, B which is equals to 1 Tesla, and sine 90 degree because they said the plane was perpendicular. Force which is equals to 2 cube, which is 4 sine 90 is 1. So for 8, force which is equals to 8 sine 90 is 1. So it is force which is equals to 8 Newton. Now let's go to the next question. A long straight conductor carrying a current of 2 ampere is in parallel to another conductor of length 5 centimeter and carrying a current of 3 ampere. They are separated by a distance of 10 centimeter. Calculate a magnetic field due to first conductor at the location of second conductor. B, the force on the second or short conductor. Solution: they gave I1 which is equals to 2 ampere and I2 which is equals to 3 ampere. And distance between them is 10 centimeter. So magnetic field which is equals to mu naught I by, or mu naught I1 on the second conductor, so mu naught I1 by 2 pi r, or 2 pi d in this case, is equals to 4 pi into 10 power minus 7 by 2 pi 1s are 2s are into I1 which is 2 ampere by 2 pi distance which was 10 centimeters, so 10 into 10 power minus 2. The finally value we will get it as 4 into 10 power minus 6 Tesla. Now force, if you want to find out, force which is equals to mu naught I1 I2 by 2 pi r into L. This is B into ILB. Same formula we are substituting here, but in B space we are substituting the formula. F is equal to, we will get it as mu naught I1 by 2 pi r. We got it as 4 into 10 power minus 6, and I2 we know it's 3 ampere into L, which is 5 into 10 power minus 2. 12 5s are 60. 60 into 10 power minus 8 is equals to 6 into 10 power minus 7 Newton, or 600 nanonewton. Let's go to the next question. Example, next question, which is a circular loop of area 1 centimeter square carrying a current of 10 ampere is placed in a magnetic field of 2 Tesla J cap, meaning acting in the y-axis. The loop in xy plane with current flowing in the clockwise direction. Find torque on the loop. We know the formula for torque, which is magnetic moment times magnetic field. Torque tau, which is equals to m cross b, which magnetic moment vector, which is basically NIA cross b, and When we take the direction of magnetic moment of such a vector, they said it if this was the xy plane, this is the direction of current. So if we use the right hand thumb rule, the magnetic moment and magnetic field should be inside, meaning it should be minus k cap. The direction of magnetic moment should be minus k cap. So substituting values, we will get tau, which is equals to 10 ampere, since only one turn, one a vector, which is in the 10 power minus 4 is the area, and it's acting in the minus k cap, cross 2 j cap, which cross product, which is sine theta. Sine 90 is 1, so we will get it as 10 into 2 into 10 power minus 4 I cap, which is same as tau, which is equals to 2 into 10 power minus 3 Newton meter, or yeah, which is Newton meter, in the I cap direction, in the x-axis. And we give it a circular loop. Now let's go to the next question. A metallic wire is folded to form a square loop of side A. It carries a current I and is kept perpendicular to a uniform magnetic field. If the shape of the loop is changed from square to circle without changing length of wire and current, the amount of work done is, this is through change in potential energy, so work done, which is equals to initial potential minus final potential energy, which is minus m magnetic moment final times b, which is initial torque, final torque, minus of minus m initial B. There is a negative here is because cos 180 is minus 1. We can write this as MIB minus MFB, which is equals to M, which is equals to NIAIN, or IA basically. IA, that is initial, that is circle. Magnetic field we can take outside, current we can take outside. A final. BI common, A initial minus A final, which will be equal to IB A square common, 1 minus 4 by pi, which is because the initial area, which was a square, which is equals to A square, and the final area, which was a circle, which is pi r square. And to find radius, since the total length of the wire, which is equals to 4a, which is equals to 2 pi r, which is the circumference, radius, which would be equal to 1s are 2s are 2a by pi, is equals to radius, so it will be 2a by pi whole square pi, which is equals to a final. And by substituting 2a by pi whole square pi, this will be the final, and by substituting the value we will get it as 4a square by pi. By taking a square common from here and here, we will get final work done to be this much. Where work done is equals to IBA square 1 minus 4 by pi. Let's go to the next question. A flat disk of radius A carries an excess charge on its surface if of surface charge density sigma, that is unit is coulomb per meter square, sigma coulomb per meter square. Consider The disk is rotated around the axis, passing through its center and perpendicular to its plane with an angular speed omega radian per second. If B is the magnetic field, is D perpendicular to rotation axis, then find torque acting on the disk. Solution: dq, which is equals to sigma 2 pi r dr, where sigma is surface charge density, charge by area, which gives sigma, and based on this we will get I, which is equals to q by t, which is equals to 2 pi r dr by 2 pi times omega, which we will get I, which is equals to omega r dr with sigma omega r dr. Torque, which is equals to magnetic moment, that is I times A cross B d torque, which is equals to I, which is outside, d area cross B, which is equals to d tau omega sigma omega r dr. Pi r square is the area, pi r square b sine 90 is 1, since they said it's perpendicular, and this r we can multiply to become r cube. This is glitching too much. Sine 90 is 1. D tau, if we integrate it, we will get it as these values outside. We will get tau to be equal to pi omega, pi sigma omega, b a power 4 by 4. This integration is from 0 to a. Array is the total radius of the ring. Next example, that is a loop carrying current I is lying in the plane of the paper. It is present in the field of a long straight wire with constant current I naught, that is inward. Find torque acting on the loop. They said a loop carrying current I is lying in the plane of a paper. It is present in a field of a long straight wire with constant current I naught inward. Then find the torque acting on the loop. The figure is something like this. This is the current I naught inward. There's a weird loop. The loop is something like this. I, I, and I. This is I naught. Now let's assume the angle it's making here is 2 theta, and this distance is A, and this whole distance to be B. The field due to the current carrying conductor or wire is tangential to every point on the circular position of the loop. It will be acting tangentially to every point of the circular loop. And if we find the direction of the magnetic field, it should be something like this. This is the direction of the magnetic field, because finding the right hand thumb rule, there is no force acting on this and this segment here, because they are tangential to the magnetic field, meaning the I and B vector are lying in the same direction. So sine equals 0, sine 0 is 0. So there is no force acting in this segment and this segment. Leave that section be. Then now let's consider a small section dr here. And let's consider this distance to be r. This distance to be r. Now df, which is equals to bi dr, which is blb formula, bli formula, which will be equal to mu naught by 2 pi, the magnetic field due to this one, mu naught I naught by 2 pi r, which is the distance till that segment, dr. Right, there is also an I here. I mu naught I naught by 2 pi r dr. This is small force F acting on a single segment. Let's split this into 2 thetas, angle bisector. We took it as 2 theta. Yes, let's split this up into theta and theta, where df is equals to bi dr, is equals to I naught mu naught by 2 pi r dr, and sine theta is equals to p by b, which is equal to p, which is equals to the perpendicular distance p by the base, which we can take as r. So r sine theta is equals to the perpendicular distance p. Therefore d tau, which is equals to df cross 2r sine theta. There's a perpendicular distance, and df we know, d tau, which is equals to mu naught I naught I by 2 pi r dr, 2r sine theta. Finally, taking integrating torque, we will get torque as mu naught I sine theta by pi a to b dr, which will get it as mu naught I sine theta by pi b minus a. And why we took 2 here, this 2, is because the torque is acting upwards on one of the segments and downwards on the other segment. Now let's go to the next question. Okay, next question. The area of the coil In a moving in a moving coil galvanometer, MCG is 16 centimeter square and it has 20 turns. The B is magnetic field, which is equals to 0.2 Tesla, and the couple per unit twist of the suspended wire is 10 power minus 6 Newton meter per degree. If deflection is 45 degree, calculate the current passing through it. The information given here is the area of the MCG coil, which is equal to 16 centimeters square, and the magnetic field produced is 0.2. Wait, no, the magnetic field is 0.2 Tesla. Wait, no, the magnetic induction is 0.2 Tesla, and they give the twist of the suspended wire is 10 power minus 6 per degree. If deflection, they give 5, which is equal to 45 degree. Calculate current passing through it. Solution area, which is equals to 16 centimeters square, or 16 into 10 power minus 4 meter square. B, which is equal to 0.2 Tesla. N, number of turns, which is equals to 20. C, which is equals to 10 power minus 6 Newton meter per degree. Theta, which is equals to, or phi, which is equals to 45 degree. Now we know that I, which is equals to C theta by PAN, where C is the 10 power minus 6, theta is deflection value, B is magnetic field, A is area of coil, N is number of turns. Every value we have, substituting the value, we will get 7.03 milliampere as the current. Okay, then let's go to the next question. A coil area 100 centimeters square having 500 turns carries a current of 1 milliampere. It is suspended in a uniform magnetic field of induction 10 power minus 3 Tesla or Weber per meter square, where Weber is the unit of magnetic flux. Its plane makes an angle of 60 degrees with the magnetic field lines of induction or magnetic field lines basically. Find torque acting on coil. Find tau torque acting on coil. Solution given is that I, which is equals to 10 power minus 3 ampere, number of turns 500 turns, magnetic field which is 10 power minus 3 Tesla, alpha which is angle is 60 degree, tau equals how much? If phi is the angle of deflection, then alpha which is equals to 60 degree, phi we can calculate by 90 minus 60 degree is equals 30 degree. tau, which is equals to B IAN, magnetic moment times magnetic field, sine 5 phi tau. Finally we will get it as by substituting all the values which is provided. We'll get tau, which is equal to 2.5 into 10 power minus 6 Newton meter. Let's go to the next question. A galvanometer of resistance 95 ohm shunted by resistance 5 ohm resistance gives a deflection of 50 divisions. That is, when joined with a resistance of 20 kilo ohm and a 2-volt accumulator. What is current sensitivity SI, current sensitivity of the galvanometer? Unit for current sensitivities in division per microampere. Solution. Before that, the diagram is, they gave a circuit. There's the galvanometer. This is a 20 kilovolt resistance, a 2-volt battery, a 5 ohm resistance, 20 kilo ohm resistance, 95 ohm galvanometer, current flowing in this direction. In accordance with the given problem, the situation is depicted by a circuit diagram in the figure as here. 20 kilo ohm is much greater than resistance of shunted galvanometer. The current in the circuit will be I, which is equals to 2 by 20 into 10 power 3, which is 10 power minus 4 ampere, which is 100 microampere. Since the shunted resistance is much smaller than the 20 kilo ohm ampere, we'll take I, which is equal to 2 volt by 20 into 10 power 3 ohms, which is equals to 100 microampere. And if this current produces 50 division of deflection, which Cs, which is equals to theta by I, which is equals to 50 divisions by 100 microampere, which is equals to 1 by 2 division per microampere nearly. This is the current sensitivity. As we neglected the other resistance, this will be the current sensitivity. Okay, let's go to the next question. A galvanometer of resistance 20 ohm is shunted by a 2 ohm resistor. What part of the main current flows through the galvanometer? We are saying a galvanometer of resistance 20 ohm. It is shunted, meaning connected to a series of 2 ohm resistance. Which part of the main current flows through the galvanometer? The formula is solution is equals to Ig, the galvanometer current, which is by I, normal current. This is equals to shunted resistance by G plus S. They're asking, the question is what part of the main current flows through the, how much of the main current passes. There was basically asking Ig value. If Ig, which is equals to Ig by I, which is equals to 2 by 20 plus 2, which is 22, 1 by 11, So 1/11 a part of the main current flows through the galvanometer. 1/11 of the part of current passes through the galvanometer. A galvanometer has resistance 999 ohm, a shunt of 1 ohm is connected to it. If the current is 10 power minus 2 ampere or 10 milliampere, what is current flowing through the ampere? Ig, basically. Solution: Ig by I, which is equals to S by G plus S, which is equals to which Ig, which is equals to I, they gave 10 power minus 2 times S, that is 1 by 1000. Ig, which is equals to 10 power minus 5 ampere or 10 microampere. Now, I'll use the same color. A galvanometer has a resistance of 98 ohm if 2% of main current flows through galvanometer, then what is main current? Solution: Ig by I, which is equals to 2 by 100, 1 by 50, 1 by 50, which is equals to S by G plus S. So G plus S, which is equals to 50S, 49S, which is equals to 98 ohm. S will become 2 ohm. The shunt value is 2. Shunt value is equals to 2 ohm. Let's go to the next question. A galvanometer has a resistance of 100 ohms, a current of 10 power minus 3 ampere pass through the galvanometer. How can it be converted into an ammeter of range 10 ampere and B into voltmeter of range again 10 volt. Solution: G, which is equals to 100 ohm, Ig they gave, which is equals to 10 power minus 3 ampere, 1 milliampere. I, which is equals to 10 ampere. So if the total current passing through is 10 ampere, there should be only 10 power minus 3 ampere current passing through the galvanometer. So I by Ig, which is 10 by 10 power minus 3, which is equals to 10 power 4 ampere. And I by Ig, Ig by I, which is equals to S by G plus S. Ig by I, which is 10 power minus 4, is equals to S by 100 plus S. So it is 10 power minus 2 plus 10 power minus 4S, which is equals to S. So S should be around 10 power minus 2 ohm. 10 power minus 2 ohm as S minus 10 power minus 4, which is a negligible value, where S is already a small value, and multiplying with 10 power minus 4, we can neglect it completely, and we'll get S should be equal to 10 power minus 2. That is ohms. Now B, converting into a voltmeter, where Vg is equals to Ig times G, which we will get it to be as current is 10 power minus 3 times 100, which we will get it as 10 power minus 1 volt. We should have such that only 10 power minus 1 amount of volt will pass through the galvanometer. Where Ohm's law, which is V equals IR, so we know Ig by I, which is equals to, wait a second, not this formula, the potential difference when connected in series, I mean in parallel, will be same. N, which is equals to basically since it's a voltmeter, voltage should be 10 power minus 1. So V, which is equals to I, which will remain constant, plus I times G plus R. This is Ig. So V by Ig minus G, which is equals to R. So V, which is 10 power minus 1 by Ig, which is 10 power minus 3 minus galvanometer resistance, which is 100, which is equals to R. So it should be 100 minus 100, so it will become 0. That is not the case. Or maybe we can take this as 100. So 100 into 10 power 3, it will be, no, that is wrong too. There is another formula for this, where that is R, which is equals to G times V by Vg minus 1. That is R equals to G times 10 power minus 1, 10 by 10 power minus 1 minus 1. So we will get R, which is equals to 100, 100 minus 1, 99. So R, which is equals to 9900 ohm. Now let's go to the next question. What is the value of shunt which passes 10% of the main current through a galvanometer of resistance 99 ohm. The first formula, Ig by I is equals to S by G plus S. Ig, which is equals to 10 by I, which is equals to 100, which is equals to S by 99 plus S, where 990 plus 10S is equals to 100S. 990 is equals to 90S. 0 cancel. S, which is equals to 11 ohm. With this, I have completed moving charges and magnetism. Some of the main question models of NEET completed through 3 videos.